Hi guys, this is Mrs. Bauer here. I'm just trying to help you get caught up with some physics stuff today. A couple students came in and visited with me in my classroom and told me that it was a really big challenge to be able to do the worksheet and to be able to do the problems with displacement and vectors that were on the back side of that. So this recording is going to help you get through some of those homework problems. So it is based on this introduction of kinematics, which is the physics of motion. You should have seen this PowerPoint. Your teacher should have showed it, your substitute teacher should have showed it to you in class. You should have been able to do the study guide portion of it. We actually skipped lesson number 1, and we actually are on slide number 19, for displacement and vectors. And you should have seen this slide about kinematics and studies of motion, and you should have been able to at least do the fill in the blank part of the first worksheet. So kinematics, position x, displacement delta x, what is the simple path in the diagram? This part of the worksheet is actually from the slide. So these literally are fill in the blanks. You guys can go ahead, chat them through, talk them through with students. If you need to, and I'll show you this, I'll put this back up in a minute. I'm going to do a physics email list right here. If you type in Google Forms ZW5YMPIYDT7AOQZJ6, go ahead and put in your email. I will send you a copy of the slides. I will send you a PDF version of it so that you can get through the slides. And I'll send you these YouTube links so they can re-watch them as homework. And I'm going to put this screen back up in just a second. I just want to make sure you're able to get through all of your physics slides. So this is the worksheet you had on displacement of vectors. This front side should have been able to simply be copy and pasted right from the slides. So for example, this first slide says kinematics is the studies of motion. Right here, kinematics studies motion without thinking its cause, and so you get that right from the slide. Position x is the location where something is relative to a coordinate system called a frame of reference. And so that should be right here. The most common coordinate system is the XY coordinate system or the Cartesian coordinate system. So you should be able to fill all these blanks out. These are just right from this very first slide. The next slide is actually this next section through here. So hopefully that will help you get that. Most of the students told me they were just fine getting through that with the sub. It was this part, the homework questions on the back, that were challenging. We didn't do number 1 in class, so you're not expected to do number 1. Why is it difficult measuring a 3x5 card? We didn't do that, so you don't have to worry about that. But I do want you to answer how displacement and distance are the same and are different. We did go over that in the slides, but I imagine that your teacher, your substitute, wasn't able to go into that in detail. Just know distance is the total length of the path taken, and displacement distance is scalar. It only has magnitude, whereas displacement is a vector and it has direction, okay? So that should help you get through that first one. So let's go ahead and look at some of these questions together. So I'm going to put my writing board up here, and please feel free to pause the recording anytime you need to. I'm going to pull this up here and see if I can get the worksheet up here at the same time, okay? Sorry, the worksheet is getting kind of small on your screen, but hopefully you can look at the copy in front of you. Okay, so number 4, let's look at that. You should be able to get number 3 from your notes, but it says number 4, classify each measurement as scalar or vector. So I'm going to come over here and type and help you get some of the answers on number 4. So number 4A asks us 20 books on a shelf. So books on a shelf, that's just a number. It's not going anywhere. It doesn't have direction. So it is a scalar quantity. Okay. B asks us a car travels 25 kilometers per hour. So 25 kilometers is a magnitude. East is a direction. So it actually is a vector. Okay, so we've got that direction in there, and that's why we need to know that, okay? Let's see, the next one says, C, a plane flies 500 kilometers. 500 kilometers is actually a specific distance, but there's no direction, and so that one's tricky because it is a scalar quantity. So those are the first three. I think you can do D, E, F, G, and H by yourself. I think you would be okay. So I want you to go ahead and pause the video there and go ahead and finish those other ones, and then I'll come back and help you do number 5, which is a calculation. Okay, so let's look at number 5 together. This one's a little bit tricky. It's very, very similar to the PowerPoint slide, this one right here that says displacement in vectors. If you drive 20 kilometers east, then turn around and drive back 15 kilometers west, what is your total displacement? Okay, and then it goes by what's your distance traveled. So this is very, very similar. So you should be able to look at your notes, kind of get an idea. But if we're going to do best practices, the first thing we need to do is draw a number line. So I'm going to draw my arrow over here. Okay. And hopefully I can write in some numbers for you. Okay, and the problem says the road I live on goes east and west. One day my family decided to go west to the beach. I travel 2 miles west. So we're going to first need to start to our origin and a point in 0. So, sorry. We're going to have a 0 right here. And then we're going to go 2 miles. Sorry, it says, I do that right. Undo. 2 miles west. West would be going backwards. And then my wife realized we passed by geese of wild turkeys. So then we turn around and go back to the direction east 1/2 mile before we find the turkeys. So we're going to have a second line about right here. So I'm going to draw that and change its color so you can see it's the second line. So the first trip we're going to go is backwards. Okay. And this is the distance of 2 miles. I'm just going to write in here, smaller font. Sorry, what you mean do this? 2 miles. And then we're going to try to go back the other direction. Yeah, go ahead and do the sound effects in class. Everybody will think you're nuts. Just kidding. Okay, and we're going to go backwards 1/2 mile. Okay, so it asks us, what is the total displacement of the flock of turkeys? Okay, and so we know displacement is delta x, which is the final position minus the initial position. So I'm going to go ahead and type that into the computer for you so you can see how to write that up. Alright, so delta x in this equation is going to equal negative 2 miles subtract a positive 1/2 mile, and that's going to give us the answer negative 1 and 1/2 miles. And the reason why it's negative 1 and 1/2 is because it's telling us that it is going west. So we can actually change it and say it is 1 and 1/2 miles west. Okay, so that should give you an idea how to do number 5. Okay, and so number 6 asks us, I'm going to do it right here in this little corner where I have a little bit of writing space. It says, what is the distance I traveled to where I stopped the turkeys? And so this is a total distance. Remember, total distance is sum of all the distances traveled. So it's 2 miles plus 1/2 miles equals 2 and 1/2 miles. So hopefully with those couple more examples, now we've got 4, 5, and 6 done for you guys. If you look on the worksheet, I did print it out with the answers. Okay, so this will be so you can be able to check yourself. So I do want you to try 7, 8, 9, and 10 by yourself. If you need help, come downstairs to room 115 after school. I'd be happy to help you finish the rest of these on the board. You guys have a great day, and I'll see you soon. Actually, check that. I changed my mind. I want to look at these problems together with you. A couple students have pointed out to me that they can't see, don't know where we're getting the numbers from on 7, 8, 9, and 10. So before I sign off, we're going to go through this real quick. So number 7 says, find the following path for A in the diagram. A, the distance traveled. And so if you come over and look at this picture, see A starts at 0, okay, and then you're going to end at 7. So in our delta x equation, you would have 7 minus 0, and that's how you would get the answer that you see on your answer key, which is 7 meters. Okay, the magnitude of displacement. Magnitude of displacement is absolute value from start to finish, so that would also be 7 meters. And displacement is also 7 meters because we only traveled one distance. Okay. B is a little bit different because it's going in the opposite direction, so this is very similar to problem number 5. And so just remember that you're going to be going opposite direction, so you're going to have a different number for the absolute values. You'll have a positive and negative sign. Number 9 is looking at path C, and this one's tricky because it goes one direction, then it stops and it turns and goes back, and then it turns and goes back the 4 directions, just like problem number 5 in the last example on the PowerPoint slides. So that should help you figure out where we're getting the numbers from. See, it looks like it begins at 2, it goes over to 10, then goes backwards to 8, then turns and goes back to 10. So those would be the numbers that you would need and how they got those numbers. And then number 10, we are starting at 9 and we're going back to 3, and then we're turning again and going to 5. So that should help you find the numbers. All right, if you need more help, come downstairs and see me after school. You guys are awesome. Have a great day.